Assalamualaikum and hi. Hope you have a good day. Today I'm going to present to you the lab 5 electromagnetic wave. Okay. Okay. First let look the objective of this lab. This lab have a three objective. Firstly is to discover and understand the wave properties and behavior. Second, to predict the behavior of wave through severe medium at a reflective endpoints. And third is to understanding the standing wave. The apparatus or equipment that we use in this lab is the PET Colorado. We had to click the link of a PET Colorado simulation wave on string. This kind of the link. Okay. Okay. In this lab, like you can see for the procedure that have mentioned that in the lab report, student needs to establish your own procedure based on your observation during the lab presentation. Okay, so we have to create our own procedure on this lab 5 electromagnetic wave. Okay, this lab have a 3 wave that we can investigate. Okay, through this lab. So we create a 3 procedure of a 3 kind of wave. Okay, first is transverse, second is standing wave, and lastly is reflective wave. Okay, I will explain to you about the transverse wave, what we get from the simulation of a transverse wave. Okay, let's begin the procedure of the transverse wave. Okay, transverse wave. The procedure of the transverse wave is first use the oscillator to produce the transverse wave. Set it with no damping but have a medium tension and the fixed end. Okay, set it with no damping, have the medium tension and the fixed end. Second, set up the frequency at 1 Hz and the amplitude of 1.0 cm long. Then, for start the simulation, we had to pause to measure the amplitude and the wavelength of the wave that is transmitted to fixed end by using okay for this we have to pause them to measure the amplitude and the wavelength of the wave that is transmitted to the fixed end by using the rulers and the reference lines in the simulations given. Observe the reflective wave behavior, whether it is reflect with the inversions or without inversion. With inversion, reflect with inversion or without inversion. Check whether the size or the amplitude affects. Okay. Next, change the value of the frequency from 1 Hz to 3 Hz. After that, repeat the step 3 to 5 to get the result for 3 Hz. Okay, for this you have to change the value of frequency 1 Hz to 3 Hz, and you have to repeat the step 3 to 5 to get the result of 3 Hz. Okay, and lastly, repeat the step 2 to 6 by replacing the fixed end with the loose end and no end setup. Okay, this is procedure for transverse wave. Okay, we have used to do in the simulation what we have to use to do the simulation. Okay, yes, so the result of the transverse wave. Okay, result and discussion. Transverse wave. Okay. Figure 1 shows the wave of 1 Hz that transmits to the fixed end. Then the amplitude measured was the same as we had to set reach 1 cm for the 1 cycle. Okay, 1 cycle 1 centimeter, use the reference line to measure the 1 centimeter, and you get the 1 centimeter. Okay, amplitude of 1 centimeter of the amplitude. Okay, had one cycle for what, 3 point, the wavelength 3.8 centimeter long. For one cycle for 3.8 centimeter long. This is the result, the first result, okay, that we get from the transverse wave. Okay, it's a figure 1. Second result that we get is a figure 2, that shows the reflector wave travel from the fixed end to the oscillator. The amplitude measured to the 2 centimeter. Okay, amplitude. Okay, it travels from the 2 centimeter, that double than initial amplitude. Okay, initial amplitude just 1 centimeter, but in this figure 2, it reflect the wave travel from the fixed end to the oscillator. The amplitude is measured 2 centimeter. That means you can see that 2 centimeter. Okay. Next is figure 3. It shows the mix of the wave from the oscillator and the reflective wave, resulting a non-uniform, okay, non-uniform wave, and the increasing amplitude. Okay, what you can see here, the amplitude is increasing, okay, but it's not in a uniform wave. Okay, by resulting a non-uniform wave. We can see in the figure 3, mixed wave, non-uniform. Okay, for figure 4, you can see that the result that we get from for the figure 4 is shows, figure 4 shows when the wave is fully collide. Okay, it form a wave of higher amplitude and then measure is at 2 centimeter. Okay, amplitude we get is at 3 centimeter. This 3 centimeter for amplitude, and it's a fully collide. Okay, it's from a higher amplitude, which is measured at a 3 centimeter long. Okay, this for figure 4, the result for figure 4. Okay, this all that we get is for the 1 hertz. Okay, 1 hertz, fixed with 1 hertz. This is all for the fixed with 1 hertz. Okay, this is for a fixed with 3 hertz. In the figure 5, it shows the wave of 3 hertz transmit to the fixed end. Then the amplitude measured, same as we had to set out, which measured for 1 centimeter long. Okay. Wave motion much faster than the wave of 1 hertz. Okay. When we change it to the 1 hertz to 3 hertz, the wave of motion is much faster than 1 hertz. Okay, this is for the result that we get in the figure 5. Then this is for figure 6. Okay, in the figure 6, it shows that the reflective wave travel from the fixed end to the oscillation. The amplitude measured to be 2 centimeter. 2 centimeter is that almost double the initial amplitude. Okay, double the initial amplitude. The initial amplitude is 1 centimeter. It is measured to be 2 centimeter. Okay, almost 2 centimeter long, and almost double the initial amplitude. Okay, but the wavelength is to remain unchanged. Okay. Okay, for figure 7, the result for the figure 7 is shows when the waveform from the oscillator and the reflective wave is a fully collide, resulting a wave with a higher amplitude measured that almost at 3 centimeter. This seems like this, but it more reflected. Okay, with the higher amplitude at 3 centimeter long, this 3 centimeter long, which is shows is that the reflectance is fully collide. Okay, resulting a wave with a higher amplitude, which is measured at almost 3 centimeter. Okay, that's the result for a fixed with 3 hertz. Okay, when we change from 1 hertz to 3 hertz in the fixed end. Okay, let's look at the loose end with 1 hertz. Okay, loose end with 1 hertz, we can see it from the figure 8. Okay, this kind of figure, loose end with 1 hertz. Okay, figure 8 shows the wave of 1 hertz transmit to the loose end, then the amplitude measured same as what we had said, which is 1 centimeter, and for 1 cycle measured for 3.8 centimeter. It's still the same like our fixed end, okay, for the figure 8, and for the loose end with 1 hertz. Okay, let's look in this kind of result we get from the figure 9. For the result for loose end with 1 hertz. Okay, okay. Figure 9 shows the reflected wave that travel from a loose end to the oscillator. The amplitude measured to be 2 centimeter, that double the initial amplitude. The wavelength remain unchanged. It's still the same as the above. It's this same. The amplitude goes to 2 centimeter. Double the initial amplitude. Okay, but the wavelength remains unchanged. It has no effects the wavelength. Okay, this is for the figures 10, the result that we get from the for the loose end with 1 hertz. Okay, figure 10 shows the mix of the wave. Okay, we get to see the mix of the wave from the oscillator and the reflective wave. Okay, and the reflective wave resulting a non-uniform. This wave is non-uniform wave by increasing the amplitude. By increasing the amplitude is increasing. Okay, this is for figure 10, and this is for figure 11. The result what we get. Figure 11, this figure shows when the wave fully collide. Okay, when the wave is fully collide, it will form and have a smaller amplitude. Okay, for a loose end with 1 hertz, and from this figure we can see that the wave is a fully collide and it form a wave that's smaller amplitude measured, and that was less than 0.050 centimeter. Okay, the amplitude is less than 0.050 centimeter long. Okay, that's for the loose end with 1 hertz. Okay, let's look at loose end with 3 hertz. We change the frequency from 1 hertz to 3 hertz. Okay, this is a result after we change the frequency. Figure 12 shows the wave at the 3 hertz that was transmitted to the loose end. Then the amplitude was measured was the same as we had said, which is 1 centimeter, and for 1 cycle was measured for 1.2022 centimeter long. Okay, amplitude is at 1 centimeter, 1 cycle. Okay, so and we get the wavelength is 1.22 centimeter length. Okay, that's the first result that we get from loose end with 3 hertz. Okay, let's look at the second result. Okay, for the second result, figure 13 shows the reflective wave that travel from the loose end to the oscillator. The amplitude was measured to be 1.98 centimeter. It was almost double the initial amplitude. The wavelength remains unchanged. Okay, the almost double the initial amplitude is okay, but the wavelength still remain unchanged. This is the result. The second result for the loose end with 3 Hz. Okay. Next, figure 14 shows when the wave from the oscillator and the reflective wave was fully collide. Okay, in the figure 14, we can see that the reflective wave was fully collide by resulting a wave with the amplitude of 1.5 centimeter. This is what you can see that the amplitude is at the 1.5 centimeter long. Okay, that's all the result for the loose end with 3 Hertz. Okay, let's look at no end with 1 Hertz. Okay, this is no end with 1 Hertz result that we get. Okay, figure 15 shows the wave of 1 Hertz that transmits to no end, then to no end. Then the amplitude was measured was the same as we said, which 1 centimeter for 1 cycle, which is a measure for 3.8 centimeter. Okay, it's a no end with 1 Hertz. The amplitude is 1 centimeter long. The wavelength for 1 cycle is 3.8 centimeter long. Okay, sorry. 1 centimeter amplitude, and for 1 cycle measured for 3.8 centimeter long. This for a no end with 1 Hz. For the result, and this is the second result that we get. Figure 16 shows the wave of 3 Hz that transmit to no end, then amplitude measured the same as we had said, which was 1 centimeter for 1 cycle, was measured for 1.22 centimeter long. Okay, this is the second result that we get. After we change it, the frequency from 1 Hz to 3 Hz. Okay, my fault, I do not. Let me check. Okay, 1 Hz to 3 Hz long. Okay, this is for 3 Hz long. 3 Hz frequency of 3 Hz. Okay, we get the amplitude still the same, 1 centimeter. And for 1 cycle it was measured at 1.22 centimeter long. Okay, that's all for the transverse wave. Okay, my friend will explain to you about the standing wave and the reflective wave. Thank you for listening my presentation.
Okay, Assalamualaikum warahmatullahi wabarakatuh. So, I'm Muhammad Hakim Ibn Hussein. I will explain about standing wave. So, first of all, we use this. Here we use 2 Hz of frequency and amplitude of 1 cm. So, for the start, we get the wave like this with no noise and high tension. Okay, so after 12 seconds, we will get the result like this. So the amplitude is near the zero amplitude. Okay, for the loose end, we use the loose end and we get the result like this. So as we can see, figure shows that we have much smoother and the amplitude is even higher with loose end. Okay, then about a 10 second after that, we will get the ongoing amplitude increase. We will get the result like this. So the figure shows that ongoing amplitude increase and decrease until the time reflective wave is almost zero amplitude and the wave produced at the same rate. The time taken is about 10.37 second, like that. Okay, for the no end, okay, for the no end, we finally get the smoothest result. Okay, so figure shows the simulator when we apply high tension to the wave have no end. There will have standing produce because in existence of reflective wave. So we use to get result in this website. So this is our final result lah. We will get the perfect wave of amplitude. Alright, thank you, sir. So the next, Muhammad Haziq will continue.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Haziq bin Muhammad Zaki. I will continue for the reflective wave. Okay, for the reflective wave, we will use this function which is pulse. This is the pulse generator, and we will do 3 experiments, which is fixed end, loose end, and no end. Okay, over here we got the amplitude, pulse width, damping, and tension. For the amplitude, we set to 1 centimeter, and the pulse width we set to first is 1 second, and the damping we set to none, and the tension we set to high. Okay, let's see what will happen on our simulation. Okay, as you can see, the pulse is inverted. When it reaches the fixed end, it will invert it, and it will become like this over and over again. So according to Newton's third law, the wall exert an equal and opposite force on the string. And for the tension, it just become the pulse moves whether slower or faster. Okay, for the pulse width, if we decrease it into 0.5, the difference between 1 second is the width of the wavelength. The amplitude will be remain the same, but the wavelength is different from 1 second just now. So if we change the pulse width over here, it will change the width of the wavelength. Okay, so the first experiment, which is fixed end, will reflect with inversion. Okay, the second one, we will take a look for the loose end. Okay, we set the pulse width to 1 second, the amplitude will be 1 centimeter, and damping is none, and the tension is high. Okay, as you can see, it does not invert it. When it reached the loose end, it not inverted. Okay, same as the first experiment. If we change to 0.5, the difference is only the wavelength. Okay, for the third one is no end reflection. Okay, no end reflection. Okay, I will just set this like this. For the pulse width will be 0.5 second, and the amplitude is 1 centimeter. And if we generate pulse, it will not no reflection, because it is no end, so it will does not make any reflection and any pulse, so the pulse will be 0. Okay, so for the conclusion on the reflective wave is changing in direction of the propagation of the wave that extract the boundary between different medium. For the conclusion in the experiment, my teammate and I had learned from this lab session were to discover and understand the wave properties and behavior. We can learn about the wave properties and its behavior through this lab session. We can know the difference between what we had learned in theory and practical through this lab session. Hence, my teammate and I get to predict the behavior of the wave through varying the medium and at reflective endpoint. Varying the medium was important to predict the behavior of the wave at the reflective endpoint. If we cannot vary the medium, we cannot get to predict the behavior of the wave through the medium. So we conclude that the lab session was failed because failed to vary the mediums. After that, from this lab session, understanding the standing wave. The definition of the standing wave was a single frequency mode of vibration of a body or physical system in which of the amplitude varies from place to place, is constantly 0 at fixed point and has maximum at other points. It was called standing wave because it's produced whenever two waves of identical frequency interfere with one another while traveling in opposite direction along the same medium. The nodes were always located at the same location along the medium, giving the entire pattern an appearance of standing still. This standing wave can learn smoothly from this lab session. Okay, that's all from me. Thank you.